Hello, welcome to Flow Diagrams. Here I hope to explain to you some of the clever things we do with flow diagrams to use them in programming. First of all, let me explain some of the blocks we use. The first ones are termination blocks. They start a program, they end it. They always are rectangular in shape with little curved corners. The next one are the action blocks. These are rectangular blocks and they're always associated with doing things like add coffee, add numbers together, move forward, turn right. All the doing, the verbs are in that section. We connect the blocks using lines with arrows on them, like that. And then we come to this diamond. This is a special block. It's the decision block. And you ask a question which has a yes/no answer. So, is the cup full? Yes, no. And this enables us to branch through our program, making decisions. And we're going to apply this now to the question of making coffee. So let's consider this coffee. We pour the coffee in. Is it full? No. Continue to pour. Is it full? Yes. Stop. And this way, let's look at a flow diagram. So a flow diagram for this obviously commences with a start block, and then we move down and we have our doing block. We add the coffee. But is it full? We ask the question. No, it's not full. And we go round on this loop. And this loop will continue. Continue as long as it's not full. So we're coming down and round this loop, continuing whilst it's not full. Eventually the cup gets full. And we say yes, and then we stop. And that's the algorithm for filling a cup of coffee. Really quite simple. Let's look at something a little bit more complex. Here's a robot we use for sumo wrestling. It has a light sensor and an ultrasound distance sensor. The light sensor picks up whether it's on black or white. If it hits white, it reverses and turns. You can see it hitting the white, reversing and turning. It keeps it in the court and ensures that it doesn't zoom all over the place. It's a nice feature. But how would we describe that with a flow diagram? Let's have a look. Well, I'll just turn on the highlighter. Well, the first thing to look at is the start block. Always start with a start block. And the next thing is we're going to drive forward. So we have our action block. We come to a decision. Is the color black? If it isn't, so is color black? Yes. We continue around this loop all the way around, back to start. And then we come back to drive forward and we ask the same question. And as long as it's black, we keep on just driving forward. However, if it turns out to be white or another color, we take this branch. No. And we get into reverse. The next command is turn left. And then we drive forward again. And we get back to the main part of the program. So you can see how that flow diagram works. Let's look at the same robot, which has another feature. It has a forklift associated with it. And the forklift is activated when it sees an object at about a distance of 20 centimeters. You can see my hand comes in and the forklift rises and stays raised for about 3 seconds. That's so that it can shift another robot out of the way. A really nasty move when we were doing sumo wrestling. Let's now look at a flow diagram for this. So once again, we begin with a start command. Then we move down to our action command, drive forward. Is the object within 20 centimeters? No, everything's clear. And then that means we just go along the loop and we continue along this loop until we meet something. If we meet something and say yes, then we move to an action block, lift the forklift, wait 3 seconds, lower the forklift, and around we go. And that ensures that the whole system keeps running. Now, when you're doing your presentations and putting it on sheets, your own flow diagrams for your robots, it's quite acceptable to just do one section at a time. In computing terms, this is called doing threading, and it allows modern computers allow you run more than one program in parallel. It's a very clever thing and is very, very efficient. So it's quite acceptable for you to say, describe how your robot drives and then maybe describe how it uses its arms. But use separate flow diagrams. Okay? A few points on the challenge. The more algorithms you describe, the more points. That's assuming you're describing them correctly. The decision must make sense. So if you say no, then you should be really going on to an action which makes sense with that no decision. If it says, is there a cliff there? And you come up with the answer yes, then a logical thing to do would be to stop. Things like that. The actions must be the correct ones for yes and no. That's what we were just describing. And you can draw your flow diagrams on an A3 piece of paper. That's a useful aspect. You can get them all on one A3 piece of paper. Okay, there's your challenge. I hope you enjoy it. I'm sure you'll do really well. Good luck.